So I think that's a good number to start. And as you see, we're recording the meeting. So that's the first hint I want to bring to you. Yeah, warm welcome to the webinar by Interconnect on a DSO standard interface to facilitate flexibility throughout Europe. Yeah, I just want to briefly set the framework for it and then hand over to the first speaker. So please keep your microphones and cameras off until the guided discussion in the end. Also, like if you have questions, please post them into the chat so we can read them, and we're gonna try to tackle them in the guided discussion session at 3:30. Also, you're free to raise your hand at that point and talk up on your own if you prefer to do that. Yeah, as mentioned, the meeting is being recorded. And that being said, I would invite the participants to turn on the camera so we see everyone and maybe just say hi. Yeah, briefly about the agenda. We'll start with the Interconnect project. David Rua, Fabio Coelho, and Carlos Silva, and Peter Nemczak will present the project from various aspects. And then we will go to the project pictures, OneNet, PD for Energy, and EUniversal. And these projects are also going to join us for the discussion. Yeah, maybe just to hand the floor to the participants to quickly introduce themselves and say hi. Let's go with the agenda, David, maybe, or let's go with the projects, OneNet, PD for Energy, and EUniversal.
Okay, my name is Ulrich McKeever. I'm with Fraunhofer in Germany. We're the coordinator of the OneNet project. So as regards background, I'm an electrical engineer. I've worked for a long time in the telecom industry. For the last number of years, I've worked as a researcher before joining Fraunhofer. Thank you.
Hello from my side. This is Massimo Bertoncini, as project coordinator of BD for Energy Horizon projects. As from my background, I'm currently the director of the R&D opportunities for digital energy within Engineering Ingegneria Informatica, a very large ICT company headquartered in Italy. And I'm currently even member or participating in important activities like Smart Grid Technological Platform, Working Group 4 on digitization of energy, and even on the Gaia X, where we are dealing even with these interesting activities related to the potential of the energy data sharing. Thank you.
Okay, last but not least, I'm Pedro Marques. I work in Redes, the Portuguese DSO, and I'm project coordinator of EUniversal.
Thanks a lot. So we're going to come back to you with the project pictures at 3 o'clock. And that being said, I want to hand over the floor to David and the first presentation.
Thank you very much. So first of all, I would like to thank the invitation to be here as one of the representatives of the project. So we'll have more of my colleagues here today to present several views pertaining to this, let's say, grid-sided grid vision that we're discussing here today, particularly important for all of us. Specifically, as a project, Interconnect is dealing with this massive challenge, which is to make interoperability a practical side of the implementation of services and products within, well, different domains. One of them being the domain of the buildings, and another one being the domain of the grid side. This is where we're trying to explore, and this is just a highlight of who we are as a large consortium, that it's composed of 50 entities. And our objective is at a certain stage, which is right now what we're taking to the field, to demonstrate this interoperability capacity that we have on hosting services, ranging from energy services as non-energy service database, in several different test sites in several countries that are comprehensively demonstrating the semantic interoperability, which is one of the core and centerpieces of the project. It will be further explained by Fabio from our end. in the development of what we believe is a framework and a context to develop the different services that right now are becoming the top of the agenda. So all of this is part of what we are. So we departed from SAREP as the grounds to building up the semantic interoperability side. We built up, as you will see, a set of frameworks to achieve this interoperability and make it available also for others to build up their own ecosystems. But the purpose being overall, and in this session we'll make it clearer, also to be an active element as well as the other projects in the energy transition that the Commission so strongly supports, but also in a more dear event to us to support also the different countries in becoming more resilient, especially given the current energy crisis that we all know. So this is what we are, this is our DNA. So if we go to the next slide, you will see even the feeling that we have in terms of the project for this new challenge for the energy crisis. So our responses to the energy crisis are also tied with a way of creating services that are resilient. So I don't know if we can move to the next slide. So that's, yeah, right. Thank you. So the purpose of the project, as many others, is to ensure this resilient and this way of mapping the different structures, the different developments that we have on a set of applications that we expect to have that will take advantage not only of the demand side flexibility, which is something that we need to always procure to make sure that we can integrate safely renewable-based systems, especially distributed cases, reduce the carbon footprint of the consumption, and all in all to make sure that we engage together different stakeholders. One of them being, of course, the service providers, the technology providers that are the linkage between the different stakeholders. One of them being, of course, as we will see here today, the system operators, and in more particular, in our case, the distribution system operators, and the consumers, because ultimately the consumers will be one of the massive impactful adopters of this trend of low carbon and efficient way of using energy at the demand side. So this is typically where we see a large impact on interoperability and where we expect to mitigate this also energy crisis throughout Europe, in the sense that this has approachable technology for everyone to use and to actually deploy their own service and their own systems. So one of the things that you will see throughout our presentation here is actually the focus that we have on making this fully accessible to everyone. So we are mostly based on open source implementations, on making sure that the frameworks are available to different stakeholders, and ultimately to support different applications. So in the next slide, I'll just give you a very brief overview of what we are taking into the field. So again, keep in mind that we are reaching out to two main domains: the grid side and let's say the energy management with the grid and the demand side. And on the demand side itself, the different types of buildings that we're approaching here. And we're taking this to a large scale implementation that we'll have in the different pilots. So we are comprehensively represented in Europe, ranging from the southern side with Portugal, Italy, and Greece, to the center part with France, Germany, a bit up to the north, Belgium, Netherlands, where we hope to have opportunity to express interoperability in practical terms twofold. First of all, to clearly show that the implementation that we are doing can be applied in different contexts. So similar services can benefit from interoperability to be deployed in different contexts. And also to show that in the different contexts, we can extend the pool of, let's say, common service to very specific services that can also use interoperability. So we are dealing with energy management, energy optimization, grid support functionalities, and ultimately to use flexibility vectors under different shapes. Again, we range from domestic buildings with typical white goods and appliances such as heat pumps, such as electric water heaters, to create this flexibility, but we also look at the tertiary side, where we're looking at the large scale of things, typically with tertiary buildings, offices, supermarkets, also interventions in public buildings. So this is also part of this large concept that we have. In between, we have the end users that are formed directly as communities of users, communities of energy, also explored here with the different aspects. Again, the purpose is to show that we can reach out this using the interoperability that we started developing also in the project, stemming from, of course, SAREF. But as you will see also in the next slide, there's a path to this. So we started this with the part of SAREF and SPINE and FIWARE initiatives that we're already in, also as S2 from the grid side, where we establish different use cases. So with these use cases, in the next step, you will see that we address this either existing use cases already there where technology was existing but not interoperable, as well as cases where new technology is also being deployed to introduce this to the end users. Ultimately, we're talking always of incrementing the existing innovation because this is a high-level TRL, and it's a TRL where we're taking technology and services to the end user. So as you will see in the next step, the purpose is to build up this open ecosystem, again, based on SAREF, that has this framework to allow everyone to use the interoperability tools that we have for their own benefit. And this means that we're not establishing just a single way of producing interoperability. We're actually covering all the grounds, and to make sure that the development is put on the side and at the use of the developers, of the integrators, and providing them with the tools to build their own solutions within the same ecosystem. So the next step became naturally to have this SAREFized services and link this all together with the typical terms that we're seeing now in this area. So artificial intelligence, machine learning for the energy management, the bridging up of the existing IoT platforms, also to dive in having information back and forth to establish gamification and challenges to the end users, and to allow to build up of peer-to-peer marketplaces. And one of the points that is quite dear to this session, interfaces to the DSO. So my colleagues will dive more into detail this interaction with the DSO. And for us, this is fundamental. All in all, this is looking to shape up as, again, this demand-side flexibility-centric services, this support to multi-utility, and all in all, to showcase the cross-section nature, not only of the project, as the results achieved. So this is important because this showcases the application across different sectors. Again, ranging from the grid side to the end consumer in between, with a plethora of services that we can find, not only as final consumers, but also, for instance, as users of electric mobility. So that's also one of the axes there that we are facing in. So if we move ahead, still in the previous slide, please. This buildup of interoperability will translate into prototypes and demonstrators that are demonstrated two ways. Internalized in the sense that we have the 7 large-scale pilots that I've mentioned a while ago, and externalized in the first stage with the cascading calls. So the project also has financing to cascading calls. We're actually having ongoing the first open calls of the projects and challenges that can benefit from the use of interoperability framework that we have developed and the other tools, such as the DSO interface that will also be introduced here today, to build up their own ecosystem of solutions by companies, by entrepreneurs willing to push forward the next generation of services to cover also the same domains. Of course, closely linked with our own pilots, because there's a context to provide this in, but clearly as a first stage. But this is not the only one. In fact, all of the implementations that are being done in the project are fully open and fully available in the public domain, so to be used by anyone interested in adopting interoperability. So with the next slide, you will see the clear point we're reaching out in terms of outcomes right now. So we showcase already that we have a framework as a set of tools that can provide the semantic interoperability context and solutions to be created. We also showed that the domain representation in terms of what could be either a commodity or an asset or any other system or set of systems can also be represented and used by this framework. The impact is also clear in the sense that we are reaching out to have an impactful way of assuming this plug and play use of services. So services are there to emphasize the end use of energy and data, and all in all should not create any barriers towards their use and with it also to not create barriers to their replicability and to make sure that this replicability is done without further effort. So this is why we have this framework, which is ongoing, has the version 2.0 release, and hopefully enough, this is a rolling development. New features and new functionalities will be added in, not only from the developments and the improvements that we will register from the pilots, but also from the contributions we received from others willing to cooperate with the project. So in the next step, we see that Sarif started to address this side of representing assets, but it's also covering other grounds that can also tackle and provide support to grid service needs. Extensions have already been submitted from our end to take further what was a great idea to represent the semantic interoperability under the scope of ETSI, especially with Sarif. And there's already massive adoption by grid stakeholders you will see today and other industry stakeholders, namely manufacturers. To end up other results that we have also, so in the next step, we have these components to become full open source. This is something that the project strives to, and this is something that it's very dear to us. It's to make this available to everyone. Again, to remove boundaries, also to remove access to knowledge, and the access to knowledge that we provide is access to tools. So take this as providing everyone with the necessary fishing rods to take their own fish. And of course, one of the results we have also is the contribution to the standardization activities in the scope of ETSI, naturally because of Sarif, but also in other groups such as AIoTI. So this is the project overall, and for the demos that we have, that we successfully already demonstrated live demos, you can see several different shades here from the project, and ranging from smart charging, from demand side, flexibility, energy management, energy optimization. This is, I would say, our scope of application here. All of this only works, especially now when we're considering all of the energy crisis that we're seeing in, if we have the grid to strictly and strongly cooperate with, because all of this makes sense for energy efficiency, security of supply, and many other challenges that you know very, very well are to be covered now and even more due to the energy crisis. So this is just one idea, one of the points that we have already managed to live demo. This was something that we successfully did even with the commission already to showcase of what we are able to achieve at this stage. More to come in the next months as we finalize the project, but this is my part of the introduction. So I'll pass on the floor to Fabio, my colleague at Ines Tech, to talk a bit more of the details and how all of this is being made available and how everyone can use this for the different domains implementation. So Fabio.
So good afternoon, everybody. My name is Fabio Coelho from Ines Tech. In the upcoming slides, we're going to provide a very brief overview of the framework that Interconnect has put out as one of its key exploitable results. We call it the SIF, the Semantic Interoperability Framework. The Semantic Interoperability Framework departs from the key concept and the key semantic proposition that Interconnect as a project has put in place. That is to foster semantic interoperability in order for us to unlock two principal things. The fact that we should evolve to having digital ICT services to be autonomous and to provide machine-to-machine communication in between these services, something that, for the matter, we need semantic interoperability in order to exploit the full potential of it, and to actually provide the basis for true cross-domain and cross-sector activities, to actually provide meaningful data representations and to provide an unbiased way to characterize what data units, and the scope of using data actually means. So to unlock that, the project, of course, departed from all of the service concepts and the service data models that are within the partners and the capabilities that our consortium brings along. So connecting with what David was saying, reaching out towards the domain of buildings, ICT services, and flexibility exploitation within those buildings and assets. and the needs of the grid in order to monitor, optimize, and to foster this as linkage between the two of them, particularly to unlock services that could bring up added comfort and added safety towards the life of end users, and at the same time optimizing grid constraints and grid needs. So to do all of that, the proposition in terms of dealing with semantics, and that is the basis for the interoperability framework of Interconnect, is depicted on this slide, where we look at what are the data representations and the scope of services that were already in the field. So we departed from services that were at least TRL 4 and TRL 5 level, and we approached a way through a process to look on how could we now move into using semantic data interfaces. That is, how can we represent the data that these services are moving along, that they are exchanging to fulfill one domain, and represent it in a way using an ontology that could use and could boost the representativeness of that data in a cross-domain way. So this means that the proposition and the use of the framework by Interconnect will make the adopters depart by using synthetic interfaces, so that is the common data models, and move onwards to use data that is represented in graphs, that is annotated with what the representation of that data is, so that it could be used then by services with no human assistance in order to exchange data in a cross-domain way. So this will become the basis to explore a cross-sector and cross-domain dimension, because now services and data is annotated, is provided with what it represents. Right? So this is the basis. Of course, in Interconnect, we use the domain coming from the buildings and coming from the grid. So our project is actually SAREF-centric. So we departed from the use of SAREF, which is an ontology covering the grid and the use of IoT devices, and we extended it with actually extra representations that were not there and that were key and essential to provide this linkage between the grid and the dealing with flexibility, by actually adding flexibility representations towards our ontology. So that sets the ground to what our domain is, and afterwards in the next slide we are actually going to watch a video that the project has made that presents what the framework is. And after the video, we will come back to some extra slides to then just to show what is actually under the hood and what is the key value that we bring. So Sebastian, could you roll the video and put in full screen, please?
We live in a world where all the possibilities of the electric grid and the energy value chain are not exploited to their maximum potential. Low interoperability between different energy and IoT systems still limits the achievable energy efficiency without drastically impacting comfort of consumers. The European Commission is investing in different solutions and strategies for addressing low interoperability and pushing market leaders to adopt more open data exchange practices. Interconnect pursues a complementary approach, using semantic data and making available a framework that engages service providers, making their services interoperable and SAREF compliant. With the Semantic Interoperability Framework, SIF, Interconnect brings interoperability enablers to all stakeholders, ensuring full semantic interoperability without the need for centralized facilitators. The Interconnect SIF moves from a common approach that uses syntactic data models and explores the full potential of semantic data exchange, while ensuring security and moving towards truly plug-and-play, domain-agnostic data interfaces. And all of this on a larger scale than ever before. The main advantages of our solutions are: 1. Cross-domain semantic interoperability. 2. Framework approach, the tools that you need, the deployment that you want. 3. Geared for SAREF and validated by 50 domain leaders. SIF is composed by ontology that provides interoperability services for a specific domain set of appliances. Service store that promotes available SAREFized interoperable services. Discover and connect with the ideal choice of SAREFized interoperable services. Knowledge engine that shares information between different devices, creates interoperability between different devices, and creates new value services based on interoperability and information exchange. Generic adapters that ensures that appliances and digital services work together in an interoperable way. And P2P marketplaces that provide distributed management and validation of energy data transactions between members of communities. This is the case for the commercial uptake of the Portuguese pilot, where the Semantic Interoperability Framework is used to enable the interoperable exchange of information between platforms from distinct stakeholders, handling the internal flexibility needs and the grid. Adopting the SIF offers a semantic interface that is domain agnostic, one technical integration that can be reused for other domains. Data representation becomes the true focal point. You have the opportunity to learn by example from market leaders from our consortium who successfully achieved semantic interoperability. The interoperable energy grid of the future awaits you. Will you stay out?
So this was, of course, a promotional video that the project has built to provide and to enlighten people about, in this case, the key exploitables of the SIF. Now in this slide, we are looking a bit of what is under the hood and in the key rationale. So as you saw in the video, there are key components that enable the way of the framework to connect to services and then to, of course, explore the actual data exchange. And this is kind of depicted here on the slides, where we depart from the use of the ontology to provide this domain-centric representation, in our case SAREF. This is important because the tools itself that build the framework, as the video said, are domain agnostic, so we can reuse the framework by just adopting a different ontology to represent a different domain. In this could be beyond energy, such as health or such as agri-food, for instance. So we even look at that end, but refocusing on the grid and on the needs for the energy sector. Using this ontology SAREF allows us to then map our data and to provide knowledge dissemination. Okay, so this is the key point, and this is the basis for the semantic data exchange that the framework addresses by using and providing a catalog of all of these services, as we saw in the video, the service store, where people can go and navigate and discover services and its capabilities that are available within the ecosystem. There are interconnection points that will become the gateways towards reaching out to the services, in line with other initiatives too that provide also connectors to adopt and to integrate. In our case, these are the interconnection points that we do see here depicted on the picture. We call them the generic adapters. And then there is a key part as part of the framework itself, which is our brokering component that enables us to use what is these semantic data representations, not only to be very explicit and to provide an unambiguous representation of what data is, but also to become what is the key part on orchestrating all of the data exchange. And this is important because the framework will allow essentially two ways to propagate data between all of the services, one of them being a direct-to-direct, where we can have and impose strict security and governance policies about who are the receivers of the data that a given service, of course, provides. And this is considered a standard approach, so it's something that we must have. But beyond that, the fact that we are using this semantic representation of data enables us to be innovative in the way that we are able to disseminate data and to become very reactive upon the type of data that we want to receive. So we disconnect who are the providers of data, who are the producers of data, and who are actually the receivers. So this goes very close to adopting a user of publish subscribe, where the publishes data and the subscribers are able to use what is this domain representation of data to subscribe to what type of information they want to receive. This provides us an extra way that will be the basis to have semantic reasoning. So that is to discover new features of data and to find new links between services that are not directly connected between each other, and to do all of this in a decentralized and scalable way. This means that the components that the framework provides are not tied to a specific orchestration or to a specific deployment setup, but they are composable. So we give even to the adopters the capability to choose which one of the components they decide to deploy, having, of course, the notion that by deploying given components, they have extra features, and this means that the decision and the deployment options are at their hands. If we move to the next slide, we will see how this actually looks like by using the components. So if we consider departing from services on the bottom part of the picture, we see that these services will naturally interface with their own legacy interfaces, either with assets, either with other services, either with legacy interfaces from the read side, for instance. These services will adopt our generic adapters that are part of the framework as these gateways, and this will actually become the entry point of using the interface that will enable these services to exchange what is now semantic data between all of these adapters. And this is done by using the knowledge engine component, as we also have witnessed throughout the video. That is our semantic data broker in between. So this allows us to compose several different scenarios that in the scope of interconnect are now being deployed on the field at large scale in these 7 large scale pilots. So to finalize, if we move to the next slide, it's also important to keep in mind that the framework of interconnect is designed to be in line with other initiatives. So, for instance, with the data spaces initiative, not only because of the way the way that the components are designed, and even what their role is, the fact that we use connectors as adopters, the fact that we have cataloging of services, the fact that we have independent data brokering capabilities, but also in line with what are the expectations for the GaiaX and all of the GaiaX hubs that are being put out within Europe to have control and sovereignty control and enforcement of data that is being moved between all of these components in all of these ecosystems. So this is the final slide for the presentation of the framework. It's a high view, a bird's eye view of what the framework is. And the framework is actually the basis also for the next part of the presentation in the DSO interface that now my colleague Carlos from eRedes will detail and will address. So Carlos, please.
Thank you, Fabio. So good afternoon, everyone. My name is Carlos Silva. I work for eRedes as a project manager. eRedes, for the ones that don't know, is the distribution system operator in mainland Portugal, serving around 6 million consumers every day in its operations for the distribution networks. And in here, I would like to talk about the DSO interface, which is one of the main outcomes of the interconnect project, at least in what regards the grid side and the grid involvement in the project. And it was developed, well, this information is mostly internal, which relates to the deliverables where you can find this information about the DSO interface. But the important fact is that it was developed by a wide set of partners, which includes, of course, the grid side, represented by EREDS and EDIS, and also Electro Juliana, but also some research institutions and industry players that act on the new flexibility markets that are being exploited and tested within the interconnect project. The DSO interface was developed, let's say, in a two-phase step. Firstly, we came out with the concept for the interface, so what it should do and how it was supposed to interact within this new context of involving the consumers, namely the low voltage, the appliances, and how can we bridge these two parts of the world. How can we manage the electricity grids, and how can we leverage on the resources that are becoming part of a new interconnected system. Then we had another task to technically develop the DSO interface, so writing actually the code, coming up with a deployable version of the interface which could work with other partners and enabling these interactions to take place using the DSO interface, of course, the system that was developed, but also the other developments from the interconnect projects, such as the semantic interoperability framework, as presented by Fabio very well. Within this fair amount of work that we have done, we also depicted some guidelines and insights, both for DSOs in the first phase, but also for flexibility service providers. So the parts, the companies that will provide these kind of services, which will eventually aggregate these resources and materialize them into flexibility products that can be offered to the grid operation. So if we go over to the next slide, we have a well-represented let's say role model, which is part of these developments that we have done. We had some very specific objectives for the DSO interface to tackle, namely to allow the universal access of the distributed energy resources to flexibility and energy markets. So we wanted to test how can the grid acquire flexibility services, and how can these new resources, either PV panels, electric vehicles, or even domestic appliances, can serve the needs of the grid and make it more cost efficient. And how can we accommodate the procurement of these services within the DSO interface? So the DSO interface serves to accommodate functions such as metering data sharing and usage, also to collect the needs from the grid itself. So in which substations or lines or feeders we have a problem, and how can we transfer that knowledge to the DSO interface, and also how can we better select what are the best services to activate at a specific time. All of this we tried to do while complying with, of course, GDPR and cybersecurity standards that, as you know, are very critical and must be very well addressed in our industry. We can go to the next one. So this slide mainly summarizes the capabilities of the DSO interface from an high-level perspective. So it is a platform on the DSO side. It is instantiated on, in this case, on EREDS, which will allow for the flexibility, mobilization, and procurement. Also for the network, enhanced network observability, and also this data exchange for grid constraints. What this means is that we are also trying to leverage on the data produced by these smart devices and distributed resources to increase the observability of the network, mainly in the low voltage level, where this observability is not so developed as it is on the upper voltage levels. It also will provide open data and analytics, so leveraging on the huge amount of data that the DSO interface will process and will the data that will pass through it. It will provide that data in an aggregated format, so to comply with anonymization requirements that we are obliged to comply to, and also providing some core functionalities such as authentication, access control. This is of course needed for an interface that will manage this kind of data and this kind of actions for the grid side, so that we are always covered in this regard. Lastly, we can also, the DSO interface can also provide some high-level information about the topology and consumer connections, so that we can tackle specific zones on the grid for acquiring flexibility, which is, of course, one of the main objectives of this DSO interface. Next slide. Yeah, okay. Then here we have just, I will not delve into these architectures that we have designed for the DSO interface. The main thing to retain here is to know that we have opted out for a modular approach in the deployment of the DSO interface. So we may choose to use some services and some services to not use, in order to match the needs that we have for the grid. Of course, we will always have a flexibility management platform to mobilize the flexibility, but also we add a great deal of work in merging the DSO interface and making it easier to connect to the DSO legacy systems to obtain metering data from the consumers, and to make this data then easily accessible to consumers and also to companies that act upon this kind of activities. The important thing also to retain here is that we both make this data available through synthetic data sharing mechanisms, such as typical REST APIs, but also through the semantic interoperability framework. And this is one of the purpose of the project, is also to make this bridge and to create this ecosystem between the platforms that are part of the project and that are part of the demonstrations, to connect them all through the semantic interoperability framework, so that we all speak the same language and so that we all understand each other. So I think we can go to the maybe I can summarize it here on this slide, and then proceed with just showing you what is the first version of the DSO interface. But it basically consists on these 4 modules, I can say, that aim at doing different things. So we can manage, first of all, the users, such as the entities that are willing to provide services to the DSO, both, let's say, observability services or flexibility services. Also, the clients that are smart, or that have the resources that can help the grid in its day-to-day operation. Another module to manage the flexibility. This module is one of the core ones, and it allows us to create needs for flexibility for a specific time frame, for a specific amount, to receive offers that match these needs that the grid has for that specific time, and then to come up with a clearing mechanism. So how can we choose these offers based on cost effectiveness evaluation of the offers that we received, comparing to the needs that we had in the first place, and then sending these activation offers to the flexibility providers. So as you can see, we have lots of interactions happening in here. All of them will be done through this semantic interoperability framework. And also observability and fault notification. In here, we are trying to exploit the capability of the DSO interface to receive alerts of potential outages or anomalies in voltage values that should not happen, so that it can be integrated in our main system for failure observability, and then we can tackle these actions on the field. And lastly, but not the least, the open data sharing, which is a set of APIs that will also be made available, interoperable, that will enable the sharing of this data, both for the individual consumers, so that we can bidirectionally communicate the, let's say, the metering data for a specific consumer for a specific part of the day, but also this the real open data, so the anonymized data that may benefit some organizations or even research works that can leverage on this type of information that passes through the DSO interface. So maybe now I could share a bit my screen just to show you what this first version of the DSO interface looks like. Okay. Let me know if someone can see it.
We can see it, Carlos.
Okay, so now we are at basically the server where the DSO interface is hosted, and if we log in, we are prompted right away with the four main menus that I referred to in my slides, and we can see in here the registered companies that are willing to offer services to the DSO. We may choose to register these companies for specific purposes, for sharing, for us to share the data with them and them to us, also for them to provide flexibility services, to provide observability to the network. And what's the main communication pathways that we want to have with this specific entity? Is it ready to communicate via the semantic interoperability framework, or it prefers to communicate via a typical API, adopting, of course, necessarily the specificities that we impose for those APIs to happen. So we are able to configure that in here, and this all then happens in the background of the DSO interface. Then we have another layer for the clients that we can register on the DSO interface. Of course, these are demonstration clients just for the purpose of showing the interface and what kind of resources we can expect for these locations to have and to be willing to provide to the grid. Then we have also the core part of the DSO interface, I would say, not in terms of user interface, but in terms of functionality, which would be to create the needs for the network. So in here, we are able to create a need of flexibility manually, but we are also, but the main purpose of this is also to, for the DSO interface to be able to receive these needs not manually, but from the network planning tool that we have in our systems, and the DSO interface is ready, and we are right now performing that integration so that these needs are fed automatically from the internal systems of the DSO, and all of this can be done without the intervention of an operator. So in here, just creating a simple need just to demonstrate. Yeah. Okay. Yeah, this is a Zoom problem, I think. Yeah, but nevertheless, we are able to create the flexibility need. And then for the specific need, we can receive some flexibility offers that will match that need that we created in the first place and will allow us to solve the problem that we intended to do. And then last, we have the observability part of the DSO interface, and also some tab for just to check the operations that were made in the interface, so that we have, if we have any problem, we can tackle what happened. So this summarizes the intent for the DSO interface, the status. If you want to know a bit of more information, you can always check the deliverables and also get in touch with ourselves in the Interconnect project. And for ending this presentation, I would like to show you a brief video similarly to what was shown to the Semantic Interoperability framework. So I will just share it now. I think I have just to enable sound sharing for this to be well transmitted. Okay, I will start playing it now.
The continuous growth of distributed renewable generation and energy storage systems, together with the expected increase in active customers engaged in demand response, poses several challenges in system operators' current planning and operational practices. A key issue to be addressed on the path to energy transition is how to incorporate the demand-side flexibility services from distributed resources to solve different technical issues, such as ensuring resilience, efficiency and reliability for modern electrical grids. European initiatives are designing possibilities for future local flexibility markets. Also at the regulatory level, new network codes are being considered to address this topic. Industry should start operationalizing systems to leverage such tools to provide the most cost-effective way to manage the electricity grid. Interconnect is also addressing these issues. Therefore, we are developing a technology called DSO Interface. This technology will act as one solution that will support multiple interactions with different entities. It will leverage on semantic interoperable technologies. It also fosters an open bilateral data exchange perspective between DSOs and sector stakeholders. The DSO interface emerges as a system which brings important innovations to the future flexibility services provisioning and to the energy system infrastructure. The DSO interface ensures access to new standardized flexibility products provided by smart homes, buildings and communities in new marketplaces through a fully interoperable interface with semantic interoperable mechanisms, including SAREF. It is based on a modular and containerized approach, which allows the interaction with legacy DSO systems. The DSO interface is materialized as a system that serves as a gateway between the internal systems of the DSO and external entities. It is currently deployed on the cloud and is composed by different modular components. Through its running services, it will allow for the mobilization and procurement of flexibility from residential and commercial buildings, the gathering of grid observability data, availability of open data and analytics, amongst others. The DSO interface will work as the grid enabler for flexibility and data services, which will symbiotically benefit the cost-effective operation of the grid and the emergence of new opportunities and services for consumers. Are you prepared for the next step?
Okay, so this was the presentation about the DSO interface. So now I pass on the floor to my colleague Peter from Cybergrid, which will present these guidelines for flexibility service providers.
Thank you. So I'm actually left with 5 minutes, and I will try to do my best to keep on time. Can you see my, yeah, okay. Next slide, please.
Peter, could maybe you share your slides, because I think I haven't included them accidentally.
Okay.
Sorry.
Problem, just give me a second. Can you see the screen now? Can you see now the screen?
Yes, it's on.
Okay, let me see. And now?
Yes, full screen.
Perfect, thank you.
Perfect. Yeah. The presentation that I would like to give you today is about the deliverable 4.4, which was actually finished a couple of weeks ago. It's not yet publicly available, but will be in the next few weeks, available on the Interconnect website. And it's meant for flexibility service providers to better understand what is expected from them. So let's put ourselves now in the flexibility provider's shoes and, you know, ask ourselves, what do we need to achieve to be able to join such DSO market, join such a DSO platform that Carlos just showed us in previous presentation, and not just what kind of technical requirements we need to fulfill in terms of interoperability, data exchange, etc., but also what kind of market requirements are there for us to fulfill in order to be able to join such market and provide offers and trade flexibility. So that's actually the main challenge for the FSP, to fully understand what is expected and what they need to fulfill. By having these clear rules, and also they need to be transparent, the DSOs would drastically decrease the costs and time to market for flexibility service provider, thus giving much better chances for better liquidity of these markets, since the markets for the DSOs are expected to be quite local, on medium voltage or even low voltage levels, where we can't expect to have such flexibility pools as we can have them on the transmission level when flexibility service providers offer frequency services. And in this deliverable, we tackle also some market requirements and the products, but also we actually tackle the TSO-DSO coordination so that we don't actually get into some difficulties among, so that if flexibility service provider would be offering ancillary services for frequency regulation, and at the same time there would be issues on the distribution level, and by providing services for the TSO at the same time, there would be issues caused to the DSO. So this is something that we would like to avoid, and this is also addressed in this deliverable. On a high level, if we look what we touched in these deliverables, so you will find some market workflows to better understand how markets function, and also what kind of services and products can be traded on these markets, and also what kind of specifics these services and markets have in order to fulfill DSO requirements for voltage control or congestion management. Then very important part of the deliverable is pre-qualification and registration of flexibility service providers. So this is something that is done with the help of the processes that are already defined for the balancing markets for ancillary services for TSOs. Since this is the standard procedure that is known for years now, and flexibility service providers are already pre-qualified at many different TSOs across Europe. So there is a lot of knowledge, know-how, practical experiences. So we were sourcing quite a lot from this area in order to see and to define what kind of pre-qualification and registration guidelines we could propose to DSOs to follow, so that the FSPs could have this as transparent as possible. Then we also checked with the pilots how they actually are tackling these issues within their pilot areas. We described also the flexibility procurement, and at the end we give some recommendations for further action, but also for DSOs to consider certain aspects of providing level playing field for FSPs, but also to decreasing the barriers for FSPs to actually enter the market. Here you can see the market phases. So it's quite similar to the TSO level. Of course, we have the reserve contracts. We have to know what are the needs on the grid. Then we have, of course, the energy part, the energy bits, delivery of the service, settlement and reporting. The important part is also DSO coordination that I mentioned before. However, in the beginning, everything starts with the registration and pre-qualification. And these two market phases are actually the ones where we would like to really emphasize the need for harmonization and the need for European DSOs to come up with at least minimum level of harmonization, so that flexibility service providers wouldn't have to, adapt their platforms, change the parameters, or change the softwares that they operate in order to fulfill the requirements, different requirements of each particular DSO. We have to be aware that, on the TSO level, there are already more than 30 TSOs across Europe, and already to fulfill their requirements, it was a big challenge for flexibility service providers. With Picasso and Mari, Tere, with all these platforms, everything goes in the direction of harmonization, standardization of the markets, of the data exchange, etc., which actually further decreases the entry barriers for FSPs. However, on the DSO level, we have 100 times more players, markets, local markets, and if we miss to harmonize this market layer, then we can't expect that this market will properly develop and that we will have proper liquidity or flexibility on those markets. As you may expect, the products on these markets have technical and bid-related parameters. I will not go into details, but you can find these details in the deliverable. And these are specifically made for the DSO purposes so that DSOs can address their use cases and tackle the issues that they face on the distribution grid. For the pre-qualification, again, it is important that it is defined, published, and that FSPs can understand what is expected from them. Also, the timeline is important, that is understandable and reasonable so that they can plan the whole procedure of pre-qualification. And of course, the pre-qualification itself needs to be adapted for the DSO needs, however, also for the type of the flexibility assets that we can expect on the distribution level, which means mostly residential and small commercial loads. Of course, there can be also some larger industrial loads or large renewables. However, it needs to be done in a way that it supports portfolio-based pre-qualification and also that it supports gradual enlargement of the flexibility pools without bigger hurdles for additional pre-qualifications of these new assets. In the deliverable itself, you will find explanations of various pre-qualification topics that you can see on this slide. Of course, all are very important. However, I would stress here, and it's also among the recommendation, that also the baselines needs to be well defined, and FSPs needs to know whether the baselines are something that is defined per asset or per portfolio, or is something that even a DSO would be providing. So the rules for baselines needs to be clear, needs to be also simple to be checked, because the baselines are actually the methodology on which the verification of the delivered flexibility is based upon. So without proper baseline methodology, there is a question whether the service itself is properly remunerated. So this is one of the very important topics, and in many cases it is somehow misinterpreted or underestimated. So I would like to emphasize here that it's a very important topic and needs to be properly addressed. Okay, so that's in short. Unfortunately, I didn't make it in 5 minutes, but I hope you got the main messages from this deliverable, and when it's published, you're welcome to check it. Thank you.
Thanks a lot, Peter, for this additional perspective. So far, we have heard about interconnect, and talking about perspectives, this brings us to the projects. We would start with OneNet, then move forward to PD for energy, and finally EUniversal. So yeah, as Peter mentioned, we're a bit behind time, but this shouldn't be a larger issue. So yeah, so please, Patrick from OneNet, the floor is yours.
Okay, thank you. I'll talk about OneNet generally, and then a little bit about the IT architecture. So next slide. So starting with the vision, what we want to do is achieve a fully replicable and scalable architecture. And the idea is to operate the European electrical system as a single infrastructure, and in doing this, enabling a variety of markets to push for a universal participation of stakeholders independently of their physical location. So it's really a single market of energy for Europe and corresponding IT infrastructure to facilitate that. The next slide. So coming into this project, we brought a lot of knowledge from previous projects that creates a solid foundation for the work. The project has a concept of demo cluster that brings 15 European countries together, so that when we talk about experimenting in different market conditions and situations, we already have quite a significant part of Europe involved, and makes our results significant at a continental level. Very big project. We have 72 partners, including the 2 relevant system operator associations. This allows us to have also in terms of countries, to have a good coverage of different competences and experiences across Europe. The grid forum, Griffon, is where we involve external stakeholders. We have a set of workshops and we involve them in some of our key deliverables. And the aspiration here is that the work we do can already be part of a discussion at European level, so that our results can quickly have acceptance. Moving on. So just this gives a visualization of the demo clusters, showing where our countries are. And each cluster involves multiple DSOs and TSOs. So our vision is to have multiple use cases involving multiple DSOs, multiple TSOs, so that we can really test all possible data exchange requirements for the market. Moving on again, onto the architecture. So the main result is the OneNet reference architecture, and we have a reference implementation of the architecture as well. This was developed based on a serious review OneNet made of the best practices for market solutions and platforms, defining a set of standard products and mapping to business use cases, and defining a theoretical market framework, then linking this to grid operation to maximize the integration of flexibility. It's also based on feedback coming from the demo use cases, together with the existing results from Horizon 2020 projects and also data-driven initiatives. As you can see, it's a 3-layer architecture, starting from the bottom, what's called the OneNet participants. It's the layer in which the data are provided to the OneNet solution, and you can see that we included energy stakeholders and data sources that are the main actors involved in the OneNet ecosystem. But since it aims to be business agnostic, we also made an analysis from the data space perspective. One of the main goals of OneNet is to create a pan-European energy data network based on the data space concept in order to enable an energy data space at European level. So we also classified the OneNet participants as data source, data provider, data consumer, and service provider in order to be compliant with the data space concept. The middle layer is called the OneNet network of platforms. It's the core of this pan-European network. And here, any platform can connect to any other using the OneNet middleware and the OneNet connector. And the main goal here is to create a completely decentralized ecosystem so that all OneNet participants can interact directly with each other without any mediation by a third party. The top layer, the OneNet framework, has 3 different components. It's a decentralized middleware to connect the core system and the OneNet connector. There's an orchestration workbench, so it enables deployment of an architecture for testing and integrating the services and the data coming up from the bottom layer. And there's also a monitoring and analysis dashboard. Next slide, please. So The main aspect here is the decentralized approach, which we use for the implementation. So if you want to deploy a OneNet connector, each participant deploys an instance of it in their own environment. It enables then the communication and cooperation with the other OneNet participants. So you include it in your environment and you're able to take part in the OneNet ecosystem. So thereby participating in and creating the energy data space of OneNet. Of course, it's also able to interact with the OneNet framework, which provides the additional central features to the OneNet network of platforms. Next slide, please. So the OneNet connector, it's the main component designed and implemented in OneNet, core component of the architecture, and it's responsible for the execution of the data exchange process. We followed two important initiatives for the concept of data space, the IDSA, International Data Space Association, that provided the IDS reference model architecture, and also the FiWare Smart Energy architecture for the implementation of the OneNet connector. We used in particular the FiWare NGSI API for data exchange. We also used the IDS core services, including identity management, clearinghouse, usage control for the data exchange process. The OneNet connector, it offers a standard API for the integration of existing platforms and has a GUI for the configuration of the connector. And the GUI also offers features like data catalog and exploring the vocabularies and definition of services. So we've also included additional data services that take into account possible data services like data quality and data harmonization tool. Next slide then. So standardizing the process, we have defined a standardizing process for supporting a list of services useful for cross-platform interactions. So we've defined 10 different categories, and in these categories we've identified 64 cross-platform services, which take into account many aspects, both in the market operation and the network operation, which could be useful for the interaction between energy stakeholders. Next slide, please. So for each service, we've identified some details, a name, a description, a method for the services, the actors involved in terms of data producer and consumer, and we've mapped these actors to the HEMRA model coming from the bridge activities. We've also defined which business objects should be exchanged during this cross-platform process, the quality requirements for each business object, and the data format and standardized data models. So all these aspects are included in the vocabularies and semantic services of the OneNet connector and are very useful for making this ecosystem completely standardized and interoperable at European level. Next slide, please. So this shows the GUI of the OneNet connector. So there's the GUI allows you to access these 10 categories of cross-platform services and the services themselves. The services are based on the SIM, and they have each a specific data profile, which establishes the interoperability. Of course, these harmonized profiles are only a suggestion to support the semantic definition of the cross-platform services, and OneNet participants can use their own tailor-made profiles if they wish. Next slide, please. So advantages of OneNet, it's open to all stakeholders, and the OneNet connector is easy to deploy. It provides standardization of the cross-platform services, allowing data harmonization, which is essentially part of the definition of the cross-platform services. There's a common identity management for authorization and authentication of the OneNet participants, also of the components and central features. It's a one-to-one secure data exchange, so you only communicate metadata to a central hub, And then the actual data exchange takes place directly between the participants, the provider and the consumer. And it's easy to use, can be utilized via the GUI and also by integrating the open APIs. And finally, it's scalable, provides a seamless and secure data exchange between all the participants. So that was a short overview of OneNet. So thank you.
Thanks a lot, Patrick.
You're welcome.
That being said, we would move on to PD4 Energy, and the floor is Massimo's.
Thanks, Sebastian, and thanks to the former speakers for bringing to this common table this interesting argument of the data-driven DSO interface. Let's quickly just to come on just to the PD4 Energy projects, where I'm playing the role of the coordinator. And let's move on quickly to the next slide, please, Sebastian, where you can see how this PD4 Energy project, which is maybe not so much matter like it is currently, that there are currently bots, interconnect, and OneNets. Because as you can see, just the framework, the time framework is for having, for staying right now at months 25 over 36. So the idea and where we are moving forward is just to deploy an energy tailored big data analytics toolbox and the underlying big data management framework in order to support new business opportunities just to address the overarching energy value chain. So differently even from the other project here, the volume for 44 times. So let's try just one moment to give me
Massimo, maybe you could bring the mic closer to you so we could hear better.
How is now?
Yes, much better.
Okay, thank you. So this is the best which I can do. Okay, so differently from the other projects, the perspective which PD4 Energy is bringing to this common table is that is addressing exactly a variety of use case and API and data-driven interface, which are not only covering the regulated operators of DSO and DSOs in particular, but even covering the other part of the energy value chain. So commercial operators or even other sector like interaction with e-mobility, so transport, or even with energy efficient buildings, if you want. And in that respect, the consortium is quite wide, including 35 partners from a very large number of countries, 11. And that is creating a lot of complexity burden, but even is creating a lot of different perspectives that are instilled into these projects, and is creating a lot of added value, and I will be explaining why in the next slide. So if we go in the next slide, very quick graphical overview of this very big consortium, just not to lose our time on this, but within this blue ellipse, you could see even the 3 DSOs which are members of our consortium. So AFME Terni from Italy, Electro Ljubljana from Slovenia, and EDAS from Turkey, together with other regulated operators. We are having LS, the Slovenian TSOs, but even the Portuguese TSOs and even other operators. If we move to the next slide, let's start just to understand what is, the landscape or the perspective around which we are working. As it was already anticipated by Padraig, even by my colleague from Interconnect project, there is a huge movement, a huge discussion around this energy data space, so energy data-driven platform, hubs, data lake, but with a view to deliver this energy data space. That for the time being, it's really a hot topic, which is expected just to create a number of clear advantages for regulated entities, but even for all the energy value chain. In particular, bringing center stage this argument of cross-stakeholders interoperability. There are essentially a number of silver bullets around which we are working. In particular, what we call cross-value chain interoperability, which is going well beyond the automation protocol like CIM, but covering even via SAREF and even other harmonization efforts, covering even this very important argument of this cross-value chain interoperability. A second argument, which we consider relevant, is that you can design, you can plan in a more or less strict way any kind of data-driven DSO interface. But the problem is over there, that there is a clear lack of trust between stakeholders, both at B2B, but even at B2C level, even considering that everybody is underline more and more the importance for a consumer-centric energy systems. But for the time being, there is one of the big bottlenecks. So people in the regulated entities are continuously saying that due to strict requirements, security requirements, or other organizational requirements, there are very few data that are shareable or shared between the different stakeholders. And this is one big problem where we are working with together with our technological and even SSH solutions, together with the last bullet point. So there is even a clear market failure, a business model immaturity of the energy value chain business models. In particular, what we understood is that there is an insufficient propagation of the shared data value among energy value chain stakeholders. So there is even very low incentives for operators or for shareholders, stakeholders, especially if you go in a bottom-up way, so starting from consumers, not only residential, but even bigger consumers, to share this data unless there are some obligations. And this is the problem. The different energy is promoting a different way of working, not creating a new way for streamlining the DSO interface based on regulated process. But we are moving forward just with a view to work on how to create standardization in data building blocks in order just to improve trust. So we are not interested just to work into pre-qualification or pre-registration, which where people more expert than us is working. Peter was mentioning ESAT brilliant in this topic before, but we are working how, from the perspective of the digitization, we can bring added value in order just to address it, to mitigate these three silver bullet points, which for us are preventing, for the time being, even this data flowing and the proliferation of this clear advantage for any kind of a DSO interface. Coming to the B achievements, yes, next slide, please, very quickly. To date, you could see that we deployed a big data analytic framework, and over the top of this framework, big data analytics service families, which include 3 different archetypes of services. One service is related just to optimal management of grid and non-grid owned assets. The second one tailored to offer improved efficiency and reliability of network operation. And the third one, which is where there is less interest from the audience from today, which is on energy efficiency investment planning. If we move to the next slide. Okay, this is the conceptual architecture around which we are working. And you can see, if we could be scrolling down the slide, that in this slide, the focus is around this conceptual architecture of the governance, on the data management, where mostly similar to the other 2 projects, we are even working on SAREF, on while integrating with the fiber context broker energy SI, and even fully working towards an IDSA and Gaia X compliant connector, even considering a specific model in order to facilitate and even just to motivate a data sharing model, which we are going just to utilize the blockchain in order to create a marketplace for exchanging data with services. For instance, any kind of consumer could be even making available if 1 year consumption data, having in change, for instance, by a DSO and or any other, aggregators, some kind like 1 year of monitoring of the grid, of the power usage, for instance, in its homeowners building. If we move on to the next slide, very quickly, you can see how this concept has been actually validated along 12 larger scale pilots along the different, countries, and which are mapped along these 3 different acronyms: BD for net, BD for DER, and BD for net. Moving to the next slide, I will be even concluding my presentation just to showcase a number of very quick examples just to demonstrate how we are working in order just to stimulate this, standardized API and data, provisioning by DSO and by other stakeholders. In these examples, there is one a couple of use cases from a big aggregator in Belgium, Centrica. Use case 1, transfer learning for asset energy forecasting. Use case 2, grid-friendly asset dispatch, where we are having even big takeaways in order, especially on the use case 2, a grid-friendly demand response activation in order to mitigate congestion of voltage issues compared to conventional activation. Of course, this is the perspective from the aggregation, which is a bit different from the DSOs. But if we move to the next slide, please. We could be complement even with this example number 2 in Italy, in this small DSO based in Terni, in Umbria, in Italy. We are working on the efficient management of flexibility resource for supporting grid operation at district level, where we are implementing demand response mechanism in energy district consisting of ASMED quarter, PV plants, and EV charging station. If we go to the next slide, we can try just to understand the links between the different, example 1 and 2. So what we did is that, given the fact that we were not having a sufficient critical mass of data for the example 2, we gave the opportunity for sharing this data from Belgium to Italy by utilizing this transfer learning methodology or technologies, which is part of our toolbox. So the added value here is that, again, we are going just to create a process through some API and some data-driven interface, which are even governing the possibility for facilitating data sharing irrespective from the process, so from DSO world or from DSO if you want. But in that case, I'm showing how this was beneficial for DSO. So this is what, according to us, according to our project, is still missing. Very quickly, just to last slide from my side, part of this approach is based as well even on federated learning, especially which is making use of local information to build global knowledge. And this is again something which is ongoing and actually being implemented in example 2 in the Italian use case. Building upon different, local models which are shared by the different participants to other projects, by the different pilot stakeholders, not only the Italian pilot, but even the different pilots. Moving to the final couple of slides, the example 3, just to mention, which is deployed by Electro Ljubljana, DSO in Slovenia. And this is a problem of coordinating grid-owned asset with non-grid-owned assets in order to identify flexibility potential based on near real-time data. And as main achievement right now, we achieved the power quality prediction, fault analytics service development, and final grain consumer profiling, clustering, and flexibility assessment. As for the analytic techniques, moving to the next slide, you could see that we utilizing online learning, so a different analytics techniques. So just to demonstrate that our projects incorporate into the toolbox a variety of different configurable, say, technologies for learning. And last example, just to close my presentation, is the fourth one, is based on Tilos Island in Greece, where the local community is participating. So again, just here the the emphasis is on the local community management. There is even a clear, I would say, interaction in a full cross-sectoral fashion between energy and water. So if we go to the next slide, just to conclude, in that case, there is even, as I was mentioning before, a cross-sectoral application between energy and water, because there is even, you can see even the achievements, improved analytics based forecasting for local generation, but especially our application is for peak shaving through smart scheduling of water pumping system. What is, just to conclude, what is important from my side is that to underline that even the data models, the interplay between the DSO and water operator have been shared even in other contexts, again in the Terni Italian context, where the local DSO is even operating the water network. So there is even an interesting way for demonstrating once more the capability for, I would say, standardized data sharing, which according to us, it is the things which is still missing to this current debate in order to generate a real working data-driven DSO interface. It's everything from my side.
Thanks a lot, Massimo. So we've heard from OneNet and from EDF Energy so far. So the last project would be EUniversal. And Pedro is here to talk about that.
Thank you, Sebastian. Let's go for the last presentation. Next slide, Sebastian, please. Okay, so quickly roundup of what's behind, who's behind EUniversal. We're 19 partners, 3 DSOs, and specifically different from other projects. We have not all different from, not all, but some. We have real market platforms working together with us. Also, Centrica as an FSP. That makes some difference, as I'll explain later on. We also have research institutes that are developing tools. EDSO and EASE as associations, 2 solution providers, and Zabala as consultant. So what's this all about? We're focusing around the concept of the UMI, which is a universal market enabling interface. So another, again, an interface. That's what why we're here in this workshop. And around this interface, we're aiming to develop tools. So this smart grid tools to address different flexible market options, but always within market options, so the project doesn't work either way. And last but not least, analyzing future or present flexibility needs and services. Next, yeah. So how was the methodology we used? We developed together with Nodes, Nside, and Centrica the technical specifications, and then these were of course done after having developed and described the needs from the DSO and the offers from the market. This UMI, this interface based on APIs, I'll explain that later on, is going to be tested in this year, so in some weeks, starting in some weeks, in 3 premises, so in Portugal, Germany, and Poland. So different markets with the same interface. As Peter already explained, it was probably too early to go into registration and pre-qualification, and I won't develop so much. I'd just like to add that part of the process, of the flexibility process, must sort of match with the actual registration of retailers from the DSO point of view. So there's already a registration and sort of pre-qualification for a retailer to connect to the DSO world. And so the regulation should match that, or at least be compatible with that. It wouldn't make sense to make it all different, the 2 types of procuring. So the UMI supports the other process. We avoided the settlement because we don't have payments, but we have the last part of the settlement phase, which is the measurement, but we addressed the other stages. Next, yeah. So we made it modular, so we didn't divide it in process groups, including baseline, management of orders, the last part, the meter reading, the analysis, the list of all markets, the portfolio management, and the trade part. So we developed this using REST APIs, together with the knowledge of the market platforms, that operators that are working with us, and also with Centric. Next. So why do we say that it's modular, adaptable, and interoperable? We align on the list of field of the different resources. So we make that compatible between all of us. We agreed upon the presence of the payload data, designation, so description, how do you call what, and part of these were set to optimal. So with some of the definitions were left open because not all of the market platforms work in the same way. So they don't, some of them don't use some fields, and some define different values for each field. And so we left all the hypotheses open in order for every market platform to be compatible with the interface. So we don't close what we don't need to close. We left it open when it's possible. And so again, recapping what it's and what it's not, the UMI. So it's not a platform, it's an interface based on API rules, specs. This interlinks DSOs with market platforms and also with FSPs. It's available, openly available, so it's open source. We have it available on the project website, as you see here, its address, and it's open also in the GitHub. So the idea is to test it in the 3 locations, show that it works, and leave up to you and the whole European environment to use it for future projects, or even developing. So the next stages, we have development opportunities out of the scope of the project, so within other projects or within the will of other entities. So to upgrade it to API 3.1, to develop a client library, a test suite also, enhancing with documentation and building on the REST aspect by providing link and link templates. So there's some work to be developed. For instance, we didn't address functions which rely upon exchange of information with the DSO, and so it's a future development opportunity also. Last but not least, what's next around the future management of the UMI? So the project will end in November, next November, and until then we manage it. The project can manage it. We are paid to do it. Then, when the project finishes, there will be the need to some entity to manage it, since it's open source. And so it's the open question for the future, what will be possible to do around this issue, because this does not just concern UMI and EUniversal project, but also other projects that have similar problems and similar difficulties in the future. And so probably they could be addressed in the same way altogether. And that's all for me. Thank you very much.
Thanks a lot, Pedro, for this presentation. That being said, we would come to the guided discussion. We're a bit late by time, so it's like 13 minutes left until the official end. Maybe just 2 more words before coming to this. From the Interconnect project, we intend to write a more high-level position paper about the interface that is proposed by Interconnect. And we're going to invite you as the projects that are here, but also other interested parties to contribute to this with additional perspectives. So this is going to be a task for the upcoming months, and we're looking forward to any contributions. So if you feel like you want to contribute, please send me an email. That being said, Patrick, Massimo, Pedro, and Carlos, the floor is open for an open exchange. And for the participants, if you have any questions, please try to raise your hand if it works, or write in the chat so we notice your question.
Okay, so probably I can get started with this discussion. And first of all, it was very interesting to knowing and to hear the different perspectives from all the projects doing in regards mainly to data exchange. I could start with a question maybe for OneNet in order to keep the assigned order at the beginning of the presentations. And my question would be that, well, as the OneNet project is also delving into this interoperability and data exchange mechanisms and tools, Patrick, how would you relate the need for standardization to the harmonization of data exchange? And can you develop a bit more what the project has been done in that field?
Yeah, well, as there's lots of standards, and the standards tend not to be harmonized. So in OneNet, we've been trying to do some harmonization. So we've made these cross-platform services, which are trying to give a harmonized view of the data exchange that needs to take place between the different actors. In our case, TSO, DSO, also down to customer. So I would say in the electrical grids area, we tended to have a lot of standards which are, say, not compatible and need to be brokered between each other or harmonized. So harmonization is difficult. We tried to make a step. Now, if a step is made and it's taken further, then that harmonization could in time also lead into some kind of de facto or also real standardization. So I'd say it's a step-by-step process, and we've tried to move it along in our project.
Okay, thank you. I think it was an interesting perspective. Now I will move to BD for energy. So Massimo, thank you for your presentation, first of all. And in what regards the DSO part in this data access and data sharing mechanisms, well, we are always discussing these mechanisms to exchange and to share more and more data. And in fact, the data is here the good or the resource for the future of utilities, at least one of its resources. And within that context, so regarding the BD for energy work, what major barrier that you would like for DSOs to tackle next? So what's the let's say the most prominent barrier that you identify within these topics that we have been discussing?
Yeah. Thanks, Carlos, for this important questions, which is even totally, aligned with the background around which we are moving. To tell you the truth, it is true that to convince especially regulated stakeholders like DSOs or TSO just to share data, it is something that in principle it is extremely difficult. Again, we are not moving forward like Interconnect or other familiar projects to design a flexibility mechanism or how this DSO interface should be looking like, but we are moving just to create API connectors for data sharing, so for bilateral or multilateral data sharing. In some case, the pathways was not so easy, but the things are changed, I would say, in the last 6 months, especially with our 3 DSO and with the other 2 TSO, I would say, when they started just to understand just the potential for this, which is not only just to create one ad hoc application for only their own benefits, but it was like closing one loop. So I will be sharing certain data, like in the concatenation of the example 1 and 2, which I showed before, for the benefit of somebody else, but even grabbing some advantages maybe next time or during some similar modeling activities. Maybe next time I will not only sharing same data, but it will be necessary for me to have some other data which the same actor would be, could be sharing to my respect. Of course, crucial in this, along this, mechanism, it is not only technologies, but just to demonstrate how it is important and how in this scenario it look like, because in that sense it is even important just to create even the necessary trust, which is not only human trust but even automated driven trust. So working around just the IDSA and Gaia-X principles, which bring the concept of data sovereignty center stage. So saying that each one is owner of the data and is pinpointing the way through which this data should be accessed and used. So creating this the standardization through this European Commission level, EU-wise level, associations or or landscapes. That's, according to us, it is the way for facilitating data sharing. So, and this is something that we, again, in the last 6-8 months, it is something like the sky has been progressively changed, and now we are happy just that we can demonstrate this, cross-stakeholder data sharing and exchange.
Okay, thank you. Very good inputs. I would retain this bilateral and multilateral that you referred, sharing mechanisms for all the stakeholders, because in fact, not only one stakeholder benefits of the data sharing, but I think everyone benefits from this arrangement.
But maybe should be pinpointed even with the scenario-based analysis in front of the stakeholders. What are the concrete benefits even for stakeholder sharing their data within their privacy or other requirements conditions? Because it is not 100%, I would say, understood that in any case data could be staying at the generation point. So even with this hypothesis, stakeholders are not happy to share data. We know one each other. This is the situation. We need to find a way for demonstrating for that they can have concrete benefits in a scenario-based way, I would say.
Okay, thank you very much, Massimo. I noticed there's an hand raised, but just before opening up the floor to some questions from the audience, I would like to ask a final question to Pedro Marques, as coordinator of the EUniversal project. And since you referred this, let's say, new topic of managing open source results that come from projects or from initiatives within our European context, specifically talking about the UMEI from the Universal project, how do you foresee this management to happen in the future after the project ends?
Yeah, as I said, until the project ends, we, the project, will manage it, of course, and although, for instance, it's not in the scope of the project to develop more services, to include more services, it's possible. But until then, we're here to take care of it. After the project completion, of course, even this and other projects will need some sort of management. And this type of open source management requires a neutral entity, being it an association or, I don't know, in the last instance, it could be some sort of spin-off of the European community to do it, European Commission, sorry. We don't know, we must discuss it together within the associations and then raise it up to the Commission if that makes sense. The fact is we have a lot of open source developments within European projects, and at least some of them shouldn't be left to die when the project finishes. So some of them should be taken care of in order to make the future additional developments and keep them alive, because open source is the solution when there's no standard. And as Patrick showed, that it's a mess and it takes a lot of time to put standards on and then to make it compatible, even worse. And so if we're in a rush, and I think we're in a rush in Europe to make flexibility actionable as soon as possible, then probably the next stage, the first stage, is to rely upon open source.
Okay, great. Also thoughts on that, and I think that's really important because we do not want to keep reinventing the wheel, but also leveraging on these already preformed developments to create new solutions that do not start from scratch, specifically in our industry. So now I think we don't have much time left, but we will stay for a couple more minutes. I would like to open the floor to our audience, and I already saw an hand raised from Tom Berry. So Tom, if you want to intervene.
Yes, yes. Hello, everybody. So I work in IEC TC 57, which is the committee responsible for the Common Information Model. And for many years, I've been working related on harmonization issues. And what I would just like to bring to everybody's attention working with these EU projects is that there's a lot of good stuff going on about harmonization, about proposals for modeling. And sitting within the IEC committees, I don't see it coming forward. So it's something we all need to improve, to take the deliverables from the EU projects and bring them to the national committees who can bring them to the IEC. So I just encourage you to do that. And I also, the last speaker talking about open source, absolutely agree 100%. Open source, wonderful idea, but it is not free. It needs to be maintained. People have to be dedicated to do it, to keep it alive. So if you want a real question, what are you as the groups and the coordinators going to do about bringing your proposals for standards to IEC and Senelec and so on?
Okay, thank you, Tom. Really good topics for discussion, I think. So any one of the project coordinators would like to pick up on this topic raised?
I had already the opportunity to talk with Tom about this and other events, so I know quite well the positioning. What I can say from our end, in specific, KNX is deeply engaged on bringing this to TC57. So I don't know exactly what's the current status quo or the last discussions, but this is part of the agenda. So definitely well taken the suggestion. In fact, we are having specific partners in the consortium handling that. For sure, something to keep on a close track, because this should find its way through the IEC as well as other regulatory bodies. So I fully agree with Tom. I still think that there's a lot to be done on crossing the bridge between what it's done in the project and what it's taken exactly to the discussion bodies. I've been following more in detail the contributions to ETSI, so the working groups for SAREF, for the extensions, where our colleagues from TNO have been also quite active with us. TC57 is something that we are participating in, but so I can probably get a bit more information from our colleagues from KNX, which are indeed participating there. But it's to answer what Tom shared as a concern, which I fully support. We should have some relevant activity there because we are participating in those groups.
Okay, thank you, David. So I would propose that we listen to one more question, if someone has from the audience or even from the panel. Okay, 3, 2, 1, closed. So, so I would now pass the word to Sebastian Vogel to finish this session and to provide his conclusion remarks. Thank you, everyone, for your participation.
Thanks a lot, Carlos, and thanks a lot to all the participants. Yes, unfortunately, there wasn't too much time for the discussion. I would have liked to have more in-depth questions as well, but you can only do so much, and there's too much to talk about, obviously. So thanks a lot for everyone. Thanks a lot to the speakers. Thanks a lot for the audience for coming. I think we had quite a good participation rate, better than expected, I have to say. So I'm very happy about that. And please stay in touch. We're also gonna be busy producing results and disseminating them so everybody gets his or her fair share. That being said, have a nice evening and see you for the next occasion. Thanks a lot for coming.
Thank you very much.
Thank you.
Thank you very much.
Bye-bye.
Thank you very much.
Bye bye.
Thanks. Bye bye.